Right, should we go through these at least? Yeah. Okay, fine. So let's have a look at question 1. So you've got 5, all multiplied by 2 to the power of 3x plus 1 has got to be equal to 62. How can we solve this?
I did 5, 3x plus 1 equals log 2, 60.
Okay, not quite. Not quite. So you basically said, well, look, 5 times by... Okay, that would work, actually. That would work. So you basically took the logarithm of this thing here. So sorry, what did you say again?
5.
Yeah.
Then 3x plus 1
Yeah.
equals log 2, 62.
Okay, I'm not quite sure that's right. What I basically want, the issue is the 5 out the front. Okay? Why not get rid of that 5 by dividing by 5 for both sides? So in other words, you can say 2 to the power of 3x plus 1 has got to be equal to 62 divided by 5. And then it's more obvious, right? Then it's more obvious that, look, you've just got the base on its own. There's the power and there's some number on the right-hand side. So I think that's slightly easier to work with if you do it that way around, okay? So in other words, in this case, you get 3x plus 1 equals log to the base 2 of all of this thing. Yeah, does that make sense? So in other words, you just get the 2 to the power of something on its own on the left-hand side and just a number on the right-hand side. So in this case, if I take away 1 and divide by 3, I get x equals log to the base 3 of 62 over 5 minus 1 divide 3. Is that okay? Yeah. So if you stick that in your calculator, what do you get? So log to the base 3 of 62 over 5. Take away 1, and then all divided by 3. 0.443. Perfect. So that's a general rule of thumb when you're solving logarithm equations. Just make sure you get the thing with the power in, so the base with some power and then just some number down here. That's what you're after if at all possible. Okay. What about the next one then? 7 to the power of y plus 2 equals 9 to the power of y plus 1.
Log
Yep.
7y plus 2 equals log 9 y plus 1.
Okay, so in other words, you just took the log of both sides. Perfect. Now what?
Y plus 2 log 7 equals y plus 1 log 9.
Perfect. So just using that third law of log to bring the power down. So y plus 1 log 9. Okay.
Y log 7 plus 2 log 7.
Okay, so in other words, you're just multiplying these brackets out. Good.
Y log 9 plus log 9.
Perfect. Okay, so plus y log 9. So yeah, in other words, you're just literally taking this y multiplied by log 7, 2 multiplied by log 7. So you're just literally multiplying these brackets out. Okay, now what?
Y log 7 minus y log 9.
Okay, so you're getting all the logs on the same side, all the y's on the same side, excuse me. So you take y on this side. Equals?
Log 9 minus 2 log 7.
Yeah, because that's log 9, isn't it? Good. Log 9 minus 2 log 7, yes. Okay?
Then y
Yep.
log 7 minus log 9.
Log 7 minus log 9, yep.
Equals log 9 minus 2 log 7.
Okay, so same on the right hand side still. Okay, now what?
Then y equals log 9 minus 2 log 7 divided by log 7 minus log 9.
Okay, so in other words, you're just taking this entire bracket here, which is multiplying the y, dividing on both sides. Okay, so log 7 minus log 9. Okay, now what did you get?
6.74.
6.74, thank you. Okay, it's just a calculator job. Perfect, well done. Let's have a go at question 3. This one, okay? What did you get?
Log 7 to x plus y
Uh-huh.
equals 11 3 minus 4.
Not quite. Okay, not quite. The reason being is you can't just sort of pick and choose what you take the logarithm of. So if you're taking the logarithm of both sides, you need to take the logarithm of this side, so log of 7 to the power of 2x plus 5, and you need to take the log of the entire right-hand side. You can't just pick that bracket out because it's got the x in. Does that make sense? So it's got to be the log of the entirety of the right-hand side. Like so. Is that okay? Yes, you've got to take the log of the entirety of the right-hand side, not just pick and choose. So yeah, absolutely, you could then go from here and say, well look, I've got log of something, so log of 7, multiplied by something else. So in other words, I'm multiplying two things in the logs.
Is it 7 multiplied by 3x minus 4?
Not yet, not yet. So if you do log of a times b, what's that the same as?
Sorry.
If you do log of a times b, some number times another number, how could you separate those two logs?
Plus.
Perfect. So this would be like saying, if I write it down here, if I have log of ab, that's the same as log of a plus log of b. Okay, that's kind of what I've got here, isn't it? I've got, that's my a, that's my 7, and that's my b, that's my 11 to the power of 3x plus 4. So therefore, this should be the same as log of 7 plus log of 11 to the power of 3x plus 4. Okay, and then basically all you need to do is just bring all the logarithms with an x in over on the left-hand side. Okay, so you notice this log's got an x in, so I'm going to bring it on the left-hand side. So in other words, I get log of 7 to the power of 2x plus 5 minus that logarithm, log of 11 to the power of 3x plus 4 is all equal to, well, the only thing that's left is log 7. Then you notice, just using your third law of logarithms, you can bring that power out the front. Yeah? So, okay, what have we got? 2x plus 5 times log of 7 minus 3x plus 4 times log of 11 equals log of 7.
The 2x log 7
Mm-hmm.
plus 5 log 7
Yep.
minus 3x log 11
Yep.
plus 4 log 11
Not plus 4 log 11. Have another look.
and negative.
Yeah, that negative also gets distributed as well. So negative 4 log 11 is equal to log of 7. Good, can you tie that up for me?
2x log 7
Yep.
minus 3x log 11
Yep.
equals log 7
Yep.
plus 4 log 11
Okay, so taking that one over. Yep.
minus 5 log 7.
Perfect. Okay, so you've got all the ones with the x in isolated. Now what?
X
Yep.
equals 2 log 7
So factorise an x out. So x times 2 log 7. Yep.
minus the 3 log 11
Excellent. Equals all that thing on the right hand side. So log 7 plus 4 log 11 minus 5 log 7. Okay, now what?
and then x equals log 7
Yeah,
plus 4 log 11
excellent.
minus 5 log 7
Yep,
divided by
good.
2 log 7
Yep.
minus 3 log 11.
Excellent, well done. So now you've got x on its own. It's just a calculator job.
5 log
Okay. Thank you. So it looks scary. Like if somebody was walking in this room now and saw this on the board, they think, nah, I'm out and I'm walking out the other door. Okay, they think it looks quite scary, right? But it's not. It's just algebra. Yeah. The most complicated thing is that once you get this, so the thing which you want is in the power. This is the kind of important thing. The x is in the power, and you've kind of got different bases going along, or at least you've got sort of 11 here and a 7 here. Just take the logarithms of both sides, use your law of logs, and it all falls out. Yeah? All of this is just really algebra. It's just expanding and subtracting and adding things on both sides. So really, once you're here, well, let's say once you're here, you've brought that power down out the front, okay? Once you're there, the rest is just easy, okay? It's just basic algebra, right? Albeit it's quite long, but it's just basic algebra. Now, the reason why I left a little bit of space on the left-hand side here is because you may want to make your life a little bit easier. You see how I've got like logs of 7s hanging around left to right and center? What you could do is actually simplify this just a touch if you wanted to. So this way works. If you're happy with this way, stick with it. But I will show you there's another way of doing it. You notice that you have 7 to the power of something here and 7 to the power of something here. It's just that power is 1. And you're multiplying it by something else. Well, what you could do is just divide by 7 on both sides. So you get the same base on the left-hand side. In other words, you get 7 to the power of 2x plus 5 divided by 7 to the power of 1 is equal to 11 to the power of 3x minus 4. Does that make sense? So I've literally just taken that 7, which is being multiplied by that bracket, and divided it on both sides. Okay? Now, if I've got two things with the same base and I'm dividing them, what happens to the powers? Subtract them. So in other words, I get 7 to the power of, well, 2x plus 5, take away 1, which is 2x plus 5, take away 1.
2x plus 4.
Excellent. 2x plus 4 is equal to 11 to the power of 3x plus 4. Sorry, minus 4 as well, isn't it? Minus 4, okay? And then I just take the logarithms of both sides, and it's straightforward enough. It's similar to this kind of one here, okay? So logarithms of both sides would be log of 7 to the power of 2x plus 4 equals log 11 to the power of 3x minus 4. Bring that power down and then just basically work it through from there, okay? So 2x plus 4 multiplied by log 7 is equal to 3x minus 4 multiplied by log of 11, okay? And then you can just work it through exactly the same thing as before, so I'm not going to go through that. So does that make sense? Either way is fine. Either way is fine. If you just want to keep it nice and neat, in other words, you're going to have fewer terms, this is probably the way to go, so do your simplification first. But this way is also fine. It also works out. Okay?